Okay, students. So, in the previous lecture B1 of series B, we were discussing quantization of energy. Okay, so this L energy level is higher energy level, and if electron moves from higher energy level to the lower energy level, it will release energy, and this energy will be quantized. Okay, so if n electrons are coming down from higher energy level to low energy level, then the energy will be n times of h nu. So this is for n electrons and this is for one electron. So this is the first lecture. B1 ends here. Now we will see some important relations for radius, velocity, frequency, time period. Okay, so in the wavelength we will discuss the wavelength parameter. We will discuss in a separate video. Okay, so here we have a quantization rule that is regarding angular momentum. So the angular momentum L, its magnitude in the nth state, this is equal to n times of h cut, and if you find it classical mechanically, it will be equal to m mass into velocity into the radius. Okay, so this velocity is the velocity in nth orbit, and this is the radius of the nth orbit. And according to Bohr theory, the radius is constant because the shape of the orbit is circular. So the radius of the circle remains constant. So from here you can take idea of the velocity. The velocity will be equal to n h cut divided by mass of the electron and the radius in the nth orbit. If you compare the relation for centrifugal force and Coulombic attraction, then you will get the relation of the energy as I write below. Here you see this is the Coulombic attraction, the charge on the nucleus and the charge of the electron divided by Rn square equal to mv is the velocity, v square by r. So if you solve it, then you will get Rn. The relation for the radius will look like this. Now here we have the velocity. If you put the velocity from here, then you will get the relation for Rn. So class, here you see we have mvn square. So I have substituted the value of vn here, and it will, after solving, you will see here Rn square will be there and Rn is here. So from here you can find Rn. You need to keep in mind here that here we have h cut. If you put the value of h cut, then it will be h by 2 pi. The relation for the radius will change. Okay, so it will be like Rn. This is equal to n square h square 4 pi epsilon node divided by 4 pi square m ze square. So class, this is the result for the radius. Okay, now if we want to find out the radius of the first Bohr orbit, so first for the first Bohr orbit, the value of n, principal quantum number, this will be equal to 1, and for hydrogen atom the atomic number will be 1. If you put it here, then you will get the radius of the first Bohr orbit. So r1, this will be equal to h square 4 pi epsilon node divided by 4 pi square m, and z is 1 here, and e square, and this is, you can see this is a constant, and this constant is a node. We call it first Bohr radius, and its value comes out to be 0.53 angstrom. So you need to remember this thing. Okay, and here you see one more thing. If you want to find out the radius of the nth orbit for hydrogen, then this will be equal to n square times of a node. So this is for hydrogen, and you see for hydrogen like atoms there will be change in atomic number. So for hydrogen like atoms, the radius of the nth orbit Rn, I am writing it dash, yeah, you can write Z. Okay, so this will be equal to n square a node by Z, you can find from here. Okay, so this is how you can find the radius for hydrogen like atom and for the hydrogen atom, and this is the first Bohr radius of the first Bohr orbit for the hydrogen atom. So class, now we will find out the velocity in the Bohr orbits. So to find velocity, we will put the value of Rn in the velocity, and the velocity you get from rule of quantization for angular momentum. So here you are to substitute the value of Rn, and you will get the result like this. Okay, I have substituted this value Rn here, and this is the result. So here you will see the velocity depends upon the atomic number. If the atomic number increase, the velocity will also increase for a particular orbit, and it is inversely proportional to the quantum number. If the quantum number increases, then the velocity will decrease. So this is the thing, and you need to keep in mind here the velocity n is not taken equal to 0, because you can see if n is equal to 0, then the velocity leads to infinity. So this is physically not acceptable. So you can satisfy in the Bohr theory why we choose the minimum value of the quantum number n to be 1. Here also you can see the radius of nth orbit is directly proportional to n square and inversely proportional to z. So if the atomic number z increases, the radius of nth orbit will decrease, and n again cannot be equal to 0, because if it is equal to 0, then the radius will reduce to 0. It is again not acceptable. The another quantity, which is the frequency and time period, for this I will make a separate video of 5 minutes. Okay, thanks. So we have completed B2 lecture of the B series. Thank you class.